Right now above your head, our galaxy is broadcasting a terrifyingly simple question: where is everybody? Because by all our best calculations, the universe should be crowded, and yet it's silent, or at least it seems that way. This is the Fermi Paradox, and it still keeps some of the smartest people on Earth awake at night. Back in 1950, physicist Enrico Fermi was having lunch with colleagues, casually talking about flying saucers and interstellar travel. Then he stopped, did a quick mental calculation, and asked a sentence that would echo for decades. Where is everybody? Here's what he meant. The Milky Way is old, about 13 billion years old. Our sun is a relative latecomer. That means countless stars had a head start of billions of years to form planets, evolve life, and build technology long before Earth was even a thing. And there are a lot of stars to play with, roughly 100 to 400 billion in our galaxy alone. Observations from missions like Kepler and TESS tell us that planets are common, not rare. On average, there's at least one planet for every star. Many of them are in the so-called habitable zone, that comfortable band where liquid water could exist on the surface. So, if you imagine the Milky Way as a vast ocean, we now know it's full of islands, potentially millions, even billions, of Earth-like worlds. Doesn't that sound like the perfect setup for life to appear again and again? Now add time. Suppose just one civilization on one of those planets develops interstellar travel. Even with slow sublight ships, spreading across the entire galaxy might only take 10 to 100 million years. That sounds huge to us, but compared to the age of the galaxy, it's like a weekend road trip. Run that logic forward and you get the punchline. By now, there should have been plenty of chances for intelligent life to emerge, grow, travel, and become visible. We should see megastructures, or receive signals, or notice some cosmic footprint, but when we listen with radio telescopes, nothing. When we scan distant stars with the James Webb Space Telescope, looking for strange atmospheric fingerprints that might indicate industry or artificial light, so far only nature. That disconnect between what seems likely and what we observe is the Fermi Paradox. The universe looks set up for life, yet we see no one. So why does this still haunt scientists even today? With better data than Fermi could ever dream of. First, because the numbers have only gotten more disturbing. Decades ago, we didn't know how common planets were. It was reasonable to imagine Earth might be rare. Now we've cataloged thousands of exoplanets. We've found super-Earths, hot Jupiters, ocean worlds. We've seen rocky planets in habitable zones, orbiting stars just a few dozen light-years away. The ingredients for life are not exotic. They're everywhere. We've also detected organic molecules in interstellar clouds, on comets, even in the atmospheres of other worlds. Carbon, water, simple building blocks of life, they're written into the universe itself. If the ingredients are common and the kitchen is everywhere, why is the recipe so quiet? Second, we keep improving our ears and still hear no choir. Since the 1960s, projects like SETI, the search for extraterrestrial intelligence, have been scanning the sky for radio signals that don't look natural. Today, with arrays like the Allen Telescope Array and China's 500-meter aperture spherical telescope, we can listen deeper and in more directions than ever before. So far, nothing that stands up to scrutiny. A few intriguing blips like the famous WOW signal in 1977, but never a repeat, never a clear hello galaxy message. Every time we think we might have something, it dissolves into noise, satellites, or ordinary cosmic phenomena. Third, new theories keep making the paradox more eerie, not less. One idea is called the Great Filter. Imagine a series of brutal hurdles that life must clear to become a technological civilization. The origin of life, the jump to complex cells, intelligence, tool use, global cooperation, avoiding self-destruction. Somewhere in that chain, there might be a step that is almost impossible. If the Great Filter is behind us, it means we are extraordinarily lucky. Maybe the emergence of complex life like us is so rare that we are effectively alone in the galaxy. But if the Great Filter is ahead of us, some inevitable catastrophe that advanced civilizations can't survive, then the silence out there is a graveyard warning. Another idea is the so-called dark forest scenario. In a dark forest at night, every creature is both hunter and prey. The safest strategy is to stay quiet and hidden. Applied to the cosmos, this suggests that intelligent civilizations deliberately avoid broadcasting their presence, fearing that someone out there might not be friendly. If that's true, then shouting our existence into the void with powerful radio transmissions might not be brave. It might be reckless. There are kinder explanations too. Maybe almost everyone's using technologies we're not listening for. We've only been using radio for about a century. That's a cosmic blink. Perhaps advanced civilizations use tight laser beams, neutrino communications, or physics we haven't discovered. To them, our radio chatter is like cave paintings, or perhaps intelligence does arise often, but rarely survives its own power. Climate change, nuclear war, engineered pandemics, runaway AI, these are not just plot devices. They're real risks we're wrestling with right now. Maybe most civilizations burn bright and brief, leaving no time to become galactic wanderers. And there's the humbling possibility that we're simply not looking correctly. Our current instruments are incredible, but they cover thin slices of time, narrow bands of the spectrum, tiny patches of the sky. Expecting to catch an alien civilization in that small window might be like dipping a glass into the ocean once and concluding there are no fish. This is why the Fermi Paradox still haunts scientists. Not because it proves we're alone, but because it forces us to confront deep questions about life, intelligence, and our own future. Every new exoplanet discovered by TESS, every strange light curve studied by astronomers hunting for Dyson spheres, vast hypothetical structures that could surround a star and harvest its energy, every spectrum taken by James Webb, searching for odd atmospheric chemistry that might hint at industry. Each of these is another piece in a cosmic detective story with no ending yet. If the universe is quiet, what does that say about us? Are we the first, the last, or just the ones too young and too small to notice the others? Maybe one day, a telescope will pick up an unmistakable signal, or a bizarre planet will show signs of technology in its sky, or we'll find simple microbes beneath the ice of Europa or Enceladus, proving that life is not unique to Earth. Until then, we're left with the paradox staring back at us like a mirror. So here's the question that lingers. Is the silence out there a sign that the universe is empty, or an invitation for us to become the voice that finally breaks it? If you want to keep exploring these cosmic riddles, from exoplanets to alien megastructures, make sure you're subscribed. The universe has more questions. Let's chase the answers together.